March 1944, Rechlin-Lärz Airfield, Mecklenburg, Germany. By this point in the war, the systematic analysis of captured enemy aircraft had become one of the Luftwaffe's most crucial intelligence operations. At Air Testing Center Rechlin, the Reich's main hub for evaluating foreign aircraft, teams of engineers and test pilots worked tirelessly to uncover every possible advantage the Allies held in the skies. What they discovered in the early spring of 1944 would completely change their perception of American industrial strength and reshape their understanding of the ongoing air war over Germany. A captured P-51 Mustang arrived at Rechlin on March 6, 1944, brought in by rail from a crash site near Brandenburg. The aircraft had been shot down just 2 days earlier during the first U.S. fighter escort mission to Berlin. The pilot had perished. But the aircraft's frame remained remarkably intact, giving German engineers their most complete example yet of the fighter that was rapidly shifting the balance of aerial power over the Reich. The initial inspection was overseen by Hermann von Bombach, an aircraft development officer who would later command the Kampfgeschwader. Still inside the cockpit were the young pilot's navigation charts, tracing a route from Debden Airfield in England to Berlin and back. A staggering 100-mile round trip. The evaluation began immediately. For months, German intelligence had been tracking reports of increased Allied fighter presence deep inside Germany. But official belief held firm that no single engine aircraft could possibly escort bombers all the way to Berlin. The distance from English bases to the German capital was roughly 560 miles one way, far beyond the known range of any Allied fighter, even with external fuel tanks. This assumption was based on studies of earlier captured aircraft like the PP-47 Thunderbolt and P-38 Lightning, both of which had limited reach into German territory before being forced to turn back due to fuel shortages. However, the events of March 4 and March 6, 1944 shattered those long-held beliefs. On March 4, the 4th Fighter Group, flying P-51 Mustangs for the very first time after switching from their P-47s, escorted a small bomber formation to Berlin. Poor weather and communication problems hindered the mission. Only 32 bombers reached the target. But the significance was undeniable. American single-engine fighters had reached Berlin, fought, and returned to England. 2 days later, on March 6, roughly 660 bombers attacked Berlin in daylight. They were escorted by more than 150 P-51 Mustangs, alongside P-38s and P-47s. These fighters not only engaged the Luftwaffe over the German capital, but also accompanied the bombers home. It wasn't a fluke. The Americans had solved the long-range escort problem. General Major Adolf Galland, one of Germany's top fighter aces with over 100 victories and now serving as the Luftwaffe's General of Fighters, flew combat missions during this period despite his command role. When he personally encountered P-51 formations over Berlin, he immediately grasped the implications. His reports, filed through official channels, noted that American fighters were operating at full combat strength depot over Berlin, engaging aggressively, showing no signs of conserving fuel. They weren't flying on fumes, they had reserves. This contradicted everything the Luftwaffe's analysts had believed. Galland emphasized the P-51's superior high-altitude performance, noting that above 20,000 feet it outclassed both the Messerschmitt Bf-109 and the Focke-Wulf F-290 in both speed and maneuverability. At Rechlin, engineers focused first on how the Americans achieved such range. Measuring the P-51B's fuel capacity, they found two wing tanks holding 92 gallons each, 184 gallons total, plus an additional 85-gallon fuselage tank mounted behind the cockpit, a relatively new feature introduced in the P-51B to extend its range. In total, the aircraft carried 269 gallons of fuel internally. Its Packard-built Merlin engine, an American-produced version of the Rolls-Royce Merlin, consumed roughly 60 gallons per hour at economy cruise and about 75 gallons at normal cruise. Based on these numbers, German engineers calculated a flight endurance of about 3.8 hours, translating to a maximum range of roughly 140 miles. That was just enough for a Berlin round trip, but with no allowance for combat. Yet, combat reports clearly showed P-51s dogfighting over Berlin for 15 to 20 minutes before flying home. An impossible feat based on the numbers. The answer emerged when the Rechlin team examined the aircraft's wing structure more closely. Each wing had hardpoints fitted with fuel line connections, confirming that the aircraft could carry external drop tanks. Drop tanks were not new. The Luftwaffe had used them since the Battle of Britain. But the question was how large these tanks were, and how the Americans were producing so many for daily missions. Search teams were dispatched to recover any jettisoned drop tanks from the March missions. Luftwaffe intelligence estimated their likely release zones northeast of Berlin, where dogfights had occurred. Within 3 days, several tanks were recovered, most crushed or fragmented, but 2 arrived at Rechlin intact, their impact softened by farmland. These finds revolutionized German understanding of American manufacturing methods. Each tank was cylindrical, about 108 inches long and 22 inches in diameter, holding approximately 108 US gallons, 400 liters. With 2 tanks, the P-51 could carry an additional 216 gallons, bringing its total fuel load to 485 gallons. That meant the Mustang could now remain airborne for nearly 6.7 hours at cruise power, giving it a range exceeding 2,000 miles, easily enough to reach Berlin and return with ample fuel for combat. The mystery of the Mustang's range was finally solved. Yet what astonished German engineers most wasn't the fuel capacity itself, it was the ingenious simplicity of the tank's construction. The drop tanks weren't made of metal. Running a hand across their surface revealed a texture entirely unlike aluminum or steel. Though the exterior was coated in silver paint, it couldn't disguise the unusual material beneath. When engineers carefully scraped away a section Near the tail cone, they uncovered multiple layers of thick paper, each about 0.5 millimeter thick, compressed and laminated together with a resin-based adhesive. This wasn't a crude improvisation. It was a deliberate, well-engineered construction. The nose and tail cones were built from overlapping sheets of the same paper material, pressed into shape much like papier-mâché, with faint ridges where each layer overlapped the next. The cylindrical center section, however, was seamless, formed by wrapping continuous layers around a mold. The fuel fittings, made of precision, machined brass, were expertly sealed. Looking through the filler cap, engineers could see the tank's interior coated with a cellulose-based lacquer, designed to resist the corrosive nature of aviation fuel. Specialists in materials science were soon brought in to analyze the tank's construction. The paper was identified as kraft paper, created through a chemical pulping process that produced extremely strong cellulose fibers, the same type used in industrial packaging and heavy-duty shipping containers. The adhesive turned out to be a resorcinol formaldehyde resin, a thermosetting polymer that, when heat-cured, bonded the layers even stronger than the paper itself. Each tank was made from at least 12 layers of laminated paper, oriented to maximize strength in every direction. Inside, wooden anti-slosh baffles help prevent fuel from surging during high-speed maneuvers. The entire process was clearly standardized for rapid, large-scale production. When weighed empty, the tank came in at around 80 pounds, slightly heavier than a comparable metal version, which typically weighed between 65 and 75 pounds. But the paper tank offered a far greater advantage. It conserved strategic materials. To the technical staff at Rechlin, the implications were astonishing. The Americans had managed to mass-produce fuel tanks using non-strategic resources, paper, wood, and resins instead of scarce aluminum or steel. No specialized machinery was required. No expert welders or metalworkers were needed. These tanks could be made in any paper mill or packaging plant with minor adjustments to existing equipment. And the United States had hundreds of such factories. Even if only a small fraction were converted to this purpose, output could easily reach thousands of tanks per week. The tanks bore no serial numbers, no factory marks, no evidence of limited production. They were commodity items, mass-produced, disposable, and endlessly replaceable. German intelligence quickly began studying the capacity of the American paper industry. Before the war, the United States had produced around 12 million tons of paper per year, and that figure had only risen during wartime mobilization. Diverting even 1% of that capacity could yield over 100,000 fuel tanks per month, far exceeding operational demand. The limiting factor wasn't materials. It was simply equipment and labor. Yet, the simplicity of production meant that semi-skilled workers could assemble the tanks after only brief training. To German analysts, the paper drop tank symbolized industrial efficiency and resource optimization on a scale beyond their comprehension. Further analysis revealed more about their usage. These paper tanks were designed for one-time use only. The same resin that gave them strength also dissolved slowly when exposed to aviation fuel. Above. Reports from captured American pilots confirmed that the tanks had to be filled just before takeoff and couldn't safely hold fuel for more than a few hours without leaking. But this wasn't a problem. Fighters were always fueled immediately before flight, and the tanks were emptied and jettisoned within hours. Their disposable nature even simplified logistics. No need for recovery, cleaning, or maintenance. They were designed to be used once and discarded. Color coding also reflected American practicality. Paper tanks were painted silver, while metal tanks were painted gray. The distinction helped ground crews quickly identify the right type during fueling operations. The silver coating wasn't only visual. It also reflected sunlight, reducing heat buildup and fuel evaporation at high altitudes. Every feature of the design reflected careful engineering for mass production and field efficiency. By late March 1944, German intelligence traced the paper tank's origins to British innovation. In 1943, the British Air Ministry, facing severe shortages of strategic metals, had commissioned the development of impregnated paper fuel tanks. The Bowater Scott Corporation, a major paper manufacturer, pioneered the process. These tanks entered service with RAF squadrons later that same year. The Americans quickly recognized the idea's potential. With their vast industrial base, they adopted and scaled the design massively, producing thousands of tanks in both Britain and the United States for use by U.S. Army, Air Force, fighter groups. An innovation born of British necessity was now being exploited through American industrial power. The implications reached far beyond fuel tanks. German analysts began a systematic review of all captured Allied equipment, looking for similar examples of resource efficiency and standardized production. The pattern was unmistakable. While German optics, weapons, and metallurgy often surpassed American technology in sophistication or precision, U.S. equipment consistently excelled in manufacturing efficiency, standardization, and reliability. And, above all, in sheer numbers, American industry favored practicality over perfection. Their machines were built for mass production, easily assembled by semi-skilled labor, and designed so parts could be interchanged freely without custom fitting. Assembly. Line techniques reduced time, cost, and complexity, allowing output on an unprecedented scale. In stark contrast, German engineering prized craftsmanship and precision. Each tank, aircraft, or weapon was a technical masterpiece, hand-fitted by expert craftsmen. But that approach demanded time, specialized tools, and skilled labor, all of which were becoming scarce. The paper drop tank, simple, clever, and disposable, became a symbol of the industrial philosophy that would ultimately shape the outcome of the war. The Germans built superior machines, individually refined, masterfully engineered. The Americans built adequate machines, but in overwhelming numbers. And in the world of industrial warfare, quantity proved decisive. The production of the P-51 Mustang perfectly illustrated this truth. North American aviation had originally designed the Mustang in response to a British request in 1940. The prototype, designated NA-73, was completed a mere 117 days after the contract was signed. One of the fastest design. 2 flight cycles in aviation history. Its first flight took place on October 26, 1940. By 1944, North American was manufacturing Mustangs at 2 major plants. One in Inglewood, California, and another in Dallas, Texas. At peak output, the Inglewood facility turned out around 364 aircraft per month, while the Dallas plant added hundreds more. Combined production reached an average of 574 Mustangs per month in 1944, with numbers still climbing. By January 1945, peak monthly production hit 881 aircraft, nearly one every 2 hours. Each P-51 was a mechanical puzzle of over 15,000 parts, supplied by hundreds of subcontractors scattered across the United States. Its heart, the Packard-built Merlin engine, a licensed version of the British Rolls-Royce Merlin, was produced in Detroit at rates of over 300 units a month. Final assembly of a P-51D required roughly 22,000 man-hours. Yet the efficiency of American assembly lines meant a new Mustang rolled off the line every few hours. Reich. The sheer scale and rhythm of this system surpassed anything Germany could achieve. By comparison, Messerschmitt and Focke-Wulf combined were producing around 600 fighters per month in early 1944. Despite forced labor, emergency programs, and relentless efforts to boost output, the resource disparity was equally staggering. In 1944, the United States produced approximately 1.25 million tons of aluminum, or 2.5 billion pounds per year, a dramatic rise from just 164,000 tons in 1939. Germany's aluminum production, by contrast, peaked near 250,000 tons annually, and was already declining under Allied bombing and loss of key bauxite sources. In short, America's aluminum output was 10 times greater. The choice to make drop tanks out of paper wasn't born of shortage. It was a product of optimization. The US had more than enough metal to build every tank in aluminum, but paper was cheaper, faster, and easier to produce. It freed up critical materials for aircraft and weapons while allowing semi-skilled labor to mass produce expendable tanks in paper mills rather than factories. This was not desperation, it was efficiency. The discovery had a profound psychological effect within the Luftwaffe's technical and operational circles. The paper drop tank became a potent symbol of American industrial might and the widening gulf in resources between the warring nations. Captured examples were displayed during Luftwaffe technical briefings. New pilots were shown the tanks and asked to consider what they meant for air combat. American fighters could now escort bombers anywhere over Germany. The Luftwaffe's old defensive strategy, waiting for Allied escorts to run low on fuel and turn back, was now obsolete. To reach the bombers, German pilots would have to fight through the escorts. suffering unsustainable losses in the process. General Major Adolf Galland, head of the Luftwaffe's Fighter Command, warned of the implications throughout the spring of 1944. He emphasized again and again that the P-51 outperformed German fighters above 20,000 feet, faster than the Bf-109, more maneuverable than the F-190. With its extended range, it could escort bombers from takeoff to target and back. From this point onward, Luftwaffe interceptors would have to fight through a constant screen of Mustangs. The results were catastrophic. In January 1944, the Luftwaffe lost roughly 90 fighters, claiming around 150 Allied kills. By February, German losses had doubled to 160 aircraft, against 230 Allied losses. The pattern was unmistakable and unsustainable. The Allies could replace losses faster than Germany could inflict them. By the summer of 1944, the full weight of American air power was felt. The 8th Air Force conducted near daily raids deep into Germany. Whenever the weather allowed, Mustangs escorted them the entire way. German losses became crippling. In June 1944, roughly 350 fighters were lost defending the Reich. In July, losses climbed again. Over 350 single-engine fighters gone in the West alone, an attrition rate exceeding 31%. By August, the rate had climbed to 36%. At such levels, experienced pilots were dying faster than they could be replaced. New recruits arriving from flight schools had perhaps 150 hours of total flight time, compared to 300 hours or more for their American counterparts. Some German replacements had barely 30 hours in the actual aircraft type before being thrown into combat. The combination of inexperience, inferior numbers, and constant Allied presence made daylight operations over Germany increasingly suicidal. Galland's reports to Hitler and the Wehrmacht leadership grew increasingly dire. By September 1944, he stated it plainly. The Luftwaffe cannot win the air war. Germany lacks the fuel, the aircraft, and the trained pilots to challenge Allied air superiority. The Americans can replace losses faster than we can cause them. Their industrial capacity is beyond anything we can counter militarily. His conclusion was grim. Germany's only hope was to conserve remaining resources, defend key targets, and pray for a political settlement before total collapse. Meanwhile, the paper drop tanks kept falling across Germany throughout late 1944 and into 1945. Civilians began to recognize their distinctive silver cylinders, scattered across fields and forests. Early reports sometimes mistook them for unexploded bombs, sparking panic until authorities clarified they were empty fuel tanks. Civil defense bulletins soon circulated, explaining that these falling silver objects were harmless remnants of Allied aircraft, but their psychological impact remained profound. Seeing the skies crisscrossed by contrails, while Allied planes casually dropped hundreds of expendable tanks, sent a clear message. The Allies had resources to waste. Germany did not. By late 1944, Luftwaffe intelligence continued examining captured Allied technology, but the focus had shifted. They no longer sought to understand how Allied equipment worked. but rather to grasp the scale of the industrial chasm between the two sides. Could Germany replicate the paper drop tanks? Technically, yes. The German chemical industry could make suitable resins, and its paper mills could produce kraft paper. Practically, the chemical plants were already overstretched, producing synthetic fuels, rubber, and explosives. Resin production for disposable tanks couldn't be justified. The paper industry, too, was fully committed to military essentials, maps, packaging, and documentation. The conclusion was inescapable. The drop tanks were more than clever engineering. They were a symbol of America's overwhelming industrial advantage, an advantage that no amount of German ingenuity could overcome. By late 1944, the Luftwaffe faced a harsh reality. Extended range operations were no longer even possible. Fuel shortages had grounded large portions of Germany's air force. Pilot training had been cut to the bare minimum, and missions were limited not by the number of aircraft available, but by the amount of fuel left in storage tanks. Under such conditions, developing long-range drop tanks was meaningless. What use was extra range when there wasn't enough fuel for even short defensive sorties? To German planners, the irony was bitter. At the very moment the Americans solved their range problem with disposable paper tanks, German fighters were sitting idle for lack of fuel. It was a stark contrast. Different problems, different resources, different destinies. The Americans had more of everything: more aircraft, more pilots, more fuel, more aluminum, and a vast industrial base capable of producing in unimaginable quantities. They even had enough surplus capacity to refine and optimize ideas like the paper drop tank. Not out of desperation, but out of efficiency. Germany, meanwhile, was fighting a war of scarcity against an enemy that never ran short. By January 1945, the outcome of the war was beyond doubt. Soviet armies were approaching the Oder River, less than 50 miles from Berlin, while Western, Allied forces had recovered from the Ardennes offensive and were advancing rapidly toward the Rhine. The Luftwaffe could now offer only sporadic resistance, its efforts constrained by fuel starvation and a dwindling pool of trained pilots. At Rechlin, the Luftwaffe's main testing and research center, the study of captured American equipment continued, but it had become purely academic. Engineers documented their findings for historical record, not for application, because by then, nothing they discovered could alter the outcome. In late January 1945, German analysts completed their final comprehensive report on the P-51 Mustang and its drop tanks. Every detail was recorded. The aircraft's range, the materials used in the tanks, production estimates, and their operational significance. The conclusion was clear and chilling. The P-51 Mustang, equipped with expendable paper fuel tanks made from non-critical materials, has rendered the German heartland indefensible against American daylight bombing. Germany lacks the industrial capacity, the fuel, and the trained pilots to contest Allied air superiority. The report was filed away in the Reich Air Ministry archives. Whether anyone in the upper command ever read it remains unknown. By that stage, such technical analyses were only confirming what the battlefield had already proven. The Luftwaffe's dominance of 1940 was gone forever. By early 1945, the once feared German air arm was reduced to desperate, isolated missions, conserving every drop of fuel for attacks that could no longer change the course of the war. Overhead, American fighters roamed unchallenged, escorting bombers, attacking ground targets, and asserting complete air supremacy. Every paper drop tank that fell to the ground was a silent symbol, a reminder of the industrial gulf that had decided the air war long before the final battles. Back in June 1944, the Luftwaffe had held a massive exhibition at Rechlin, displaying captured Allied aircraft for their own personnel. Among them were P-51 Mustangs, B-17 and B-24 bombers, P-38 Lightnings, Lancasters, Mosquitoes, Typhoons, and several Spitfire variants. Thousands of Luftwaffe pilots and ground crews walked among these machines, studying their design, construction, and standardization. Prominently displayed were the paper drop tanks, accompanied by detailed technical diagrams explaining how they extended the Mustangs' reach deep into German territory. The exhibition was both an educational showcase and a sobering revelation. It laid bare the scale of Allied industrial mobilization, the sheer volume, precision, and consistency of production that Germany could never match. The Luftwaffe's KG-200, the secret unit tasked with flying captured enemy aircraft, operated several P-51s throughout 1944. German test pilots used them for evaluation flights, gaining first-hand experience of what made the Mustang so formidable. Their reports consistently praised the aircraft. They noted the excellent cockpit visibility, especially in the later P-51D model with its bubble canopy, the stability and responsiveness in flight, and the smooth power delivery of the Merlin engine. But what impressed them most was the range. With internal fuel and drop tanks, a P-51 could stay airborne for over 6 hours, flying missions that German single-engine fighters could never hope to match, even with external tanks. This understanding shaped Germany's defensive tactics during the war's final year. Realizing that Allied escorts could now accompany bombers throughout their entire route, Luftwaffe controllers tried to mass their limited forces at key points to achieve local superiority. In theory, the plan made sense. In practice, it failed. Fuel shortages, communication issues, and the sheer scale of Allied operations made coordination nearly impossible. Even when German fighters managed to form up and strike, the ever-present P-51 escorts inflicted devastating losses. The balance had reversed. In 1943, unescorted Allied bombers suffered catastrophic casualties. By mid-1944, it was the German fighters who were being wiped out trying to reach those same bombers. After the war, the once overlooked paper drop tanks became collectors' curiosities. Few survived intact. Most were shattered on impact or deliberately destroyed by Allied ground crews to prevent reuse. Their expendable nature gave them little value, and only a handful ended up in museums. Today, the National Air and Space Museum in Washington, D.C., displays several original examples beside the P-51's Mustangs they once served. Each carries an information plaque describing the laminated kraft, a paper construction, the phenolic resin coating, the 108-gallon capacity, and the companies like Bowater Scott that produced them. What the plaques don't mention is perhaps the most important detail of all: that German engineers spent weeks studying these simple paper tanks, not to copy them, but to comprehend what they represented. They were not marveling at advanced technology. The paper drop tank was deliberately simple. A disposable tool made from cheap, non-strategic materials. But in that simplicity lay a message more devastating than any weapon. The Allies had such overwhelming industrial strength that they could afford to design for mass production instead of performance. And that, more than any airplane, bomb, or battle, was what truly decided the air war over Europe. The Americans could build fuel tanks out of paper, not because they lacked metal, but because they had too much of everything else. They possessed unlimited paper, abundant resin, vast manufacturing capacity, and an endless supply of fuel to fill those tanks. This was not a desperate workaround born of shortage. It was a calculated act of efficiency. Germany's engineers understood the significance immediately. They realized they were no longer fighting a resource-starved opponent scrambling for substitutes. They were facing an enemy so rich in materials that using paper instead of aluminum was simply a choice for optimization, not survival. In the aftermath of the war, interrogations of Luftwaffe officers and technical personnel often returned to this theme. When asked when they first realized Germany was doomed, many pointed to the spring of 1944 as the decisive moment, when long-range American escort fighters began appearing in the skies over Berlin. Even Hermann Göring, interrogated after the war, admitted that the arrival of those long-range fighters had struck a major strategic blow to Germany's air defense. Whether or not he ever said the famous line about Mustangs over Berlin remains uncertain, but his post-war statements leave little doubt. Allied air superiority, enabled by long-range escort fighters, had sealed the Luftwaffe's fate. The technical legacy, the lessons learned from captured P-51 and Mustangs and their paper drop tank, didn't end with Germany's surrender. Many of the same engineers who studied these machines at Rechlin later worked for the Allies, some emigrating to the United States, others joining post-war intelligence and research programs. Their insights into American mass production methods, standardization, and design philosophy influenced aviation for decades to come. The principles of interchangeable parts, ease of manufacture, and engineering for large-scale production became central tenets of modern aircraft design. Even the paper fuel tank itself became a teaching example. in post-war engineering schools and military academies. It was studied as a case of wartime innovation, showing how efficiency and resource management could create a strategic advantage as powerful as any weapon. A legacy that endured. The P-51 Mustang continued to serve long after World War II ended. It saw extensive combat in the Korean War, where it shifted from high-altitude escort duties to ground attack and close air support. Its long range and endurance, the same qualities that had made it the guardian of Allied bombers over Europe, proved just as valuable in the skies over Korea. Remarkably, Mustangs remained in front line service with several nations well into the early 1980s. A testament to the aircraft's robust and timeless design. More than 15,000 Mustangs were built during and after the war, making it one of the most produced American fighters in history. Today, over 100 still fly, lovingly maintained by collectors and museums around the world. The sight of a P-51 in flight, often wearing its original wartime colors, bomb, remains a stirring reminder of how this single aircraft, and the ingenuity behind its paper tanks, helped secure Allied air supremacy over Europe. Industry over ideology, but the true legacy of the Mustang and its paper tanks extends far beyond their performance in combat. They embody a greater truth about industrial warfare, that wars are won not only by tactics and courage, but by production capacity and organization. World War II was ultimately decided not on the front lines, but in factories. The side that could build more weapons faster and replace what was lost held the decisive advantage. At its wartime peak between 1943 and 1944, the United States achieved an industrial mobilization the world had never seen. From Freien, American factories produced over 50,000 aircraft per year, launched multiple ships per day, and churned out billions of rounds of ammunition. This staggering output sustained not only the US military, but also armed Britain, the Soviet Union, and numerous Allied nations through the Lend-Lease program. Germany, despite its advanced engineering and industrial talent, could never match that scale. Its factories were smaller, its supply chains strained by strategic bombing, and its access to raw materials constantly shrinking as it lost territory. Even more damaging were bureaucratic inefficiencies and competing priorities that fragmented production. At its core, Germany faced a coalition whose combined industrial might was many times greater than its own. When the United States entered the war and fully mobilized its industry, by 1943, Axis defeat became inevitable. Symbols of defeat. The paper drop tanks that rained down across Germany in 1944 and 1945 became stark symbols of that reality. They represented the overwhelming power of American industry. Simple, expendable, and efficient. In contrast to Germany's dwindling resources and over-engineered precision. Throughout the war, German technical intelligence at Rechlin maintained detailed records of every captured Allied weapon and aircraft. Their engineers conducted meticulous tests, measured performance, and documented material composition, Many of those reports still survive today in archives, offering a fascinating window into how each side viewed the other's technology. German evaluations of American equipment were usually technically accurate. They recognized the strengths and weaknesses of US aircraft, vehicles, and weapons. But behind every analysis was a deeper, unspoken truth. The Americans weren't just building machines. They were building them faster, cheaper, and in quantities Germany could never hope to match. And, in the end, that difference, the power of mass production over perfection, decided the war long before the final bombs fell. Where German analysis fell short was not in their understanding of individual, Allied technologies, but in their failure to grasp the scale of American production and the enormous consequences that scale carried for the outcome of the war. A single P-51's Mustang was an excellent fighter aircraft, but 10,000 Mustangs represented something far greater. An overwhelming wave of air superiority that no amount of tactical brilliance or technical innovation could overcome. The story of German engineers examining paper drop tanks at Rechlin in March 1944 is, at its core, a story about industrial warfare itself. It revealed that in conflicts between modern industrialized powers, production capacity can be just as decisive as the battles fought, in the sky or on the ground. The side that can produce more, faster, and with greater efficiency gains an advantage that even the finest tactics cannot fully offset. This hard lesson, learned by Germany and Japan at immense cost during the Second World War, went on to shape military strategy throughout the Cold War, and it continues to influence strategic thought, even today. The ability to sustain weapon production, maintain resilient supply chains, train replacements faster than losses occur, and outproduce the enemy over long periods remains as crucial now as it was in 1944. The turning point, in March 1944, American bombers reached Berlin under the protection of long-range, single-engine fighter escorts. For the first time, this marked a turning point in the air war over Europe. From that moment onward, no German target was beyond reach. The Allied bombing campaign could now proceed with losses that, while still severe, were sustainable. German war production came under relentless pressure. Synthetic fuel plants, ball-bearing factories, aircraft assembly lines, and transportation networks all became targets for repeated attacks. Each one now escorted all the way to and from the target. The cumulative effect of this sustained campaign, combined with Soviet advances from the east and Allied offensives from the west and south, sealed Germany's fate just 14 months after the first Mustangs appeared over Berlin. The paper tank's role throughout this final phase of the war, paper drop tanks, played a crucial supporting role. Production continued well into 1945, with thousands manufactured every month. These tanks weren't just used by the P-51 Mustang, but also by the P-47 Thunderbolt and P-38 Lightning, extending the operational range of all major American fighter types. Even British squadrons made extensive use of them, particularly the Royal Air Force's Mustang units, which relied on paper tanks for long-range missions deep into occupied Europe and Germany. This innovation freed up valuable aluminum and steel for other critical uses, while still giving Allied fighters the range needed for strategic operations. It was a masterclass in industrial optimization, a perfect example of how the Allies matched production methods to operational requirements, valuing efficiency over tradition. This approach defined much of the Allied war effort, where practicality consistently outweighed prestige. Why the Allies prevailed, modern historians recognize that no single factor won the air war over Europe. Victory came from a combination of elements: numerical superiority in aircraft and pilots, advances in radar and communications, relentless strategic bombing, and the gradual exhaustion of German industry. The P-51 Mustang and its paper fuel tanks were vital parts of this larger system, but not the only decisive elements. The air war was ultimately won through the combined power of multiple fighter designs, bomber fleets, production lines, pilot training programs, intelligence gathering, and tactical innovation, all backed by unwavering industrial and economic commitment. Still, the paper drop tank stands out because it symbolizes the essence of Allied success: the ability to turn simplicity and mass production into overwhelming strength. German records and realizations at Rechlin. German engineers studied captured American aircraft and equipment with their usual methodical precision. They documented specifications, performance data, material composition, and estimated production rates, all recorded in detailed technical files. Many of these reports survived the war and are now preserved in archives such as the Bundesarchiv, providing historians with rare insights into how Germany viewed Allied technology at the time. With the benefit of hindsight, it's clear that German technical assessments were largely accurate. They correctly understood American engineering capabilities. What they failed to alter, however, was the strategic reality those capabilities represented. Knowing that the enemy possesses overwhelming industrial advantages doesn't mean one can counter them, not when those advantages are rooted in fundamental disparities of resources, manpower, and production scale. A simple solution, a profound lesson. The legacy of the paper drop tank extends far beyond its wartime role. It stands as a reminder that effective solutions do not always need to be complex or technologically advanced. A disposable tank made of glued paper, designed for one-time use, and built from non-critical materials, perfectly solved the problem of extending fighter range. It was simple, inexpensive. Most importantly, it worked. In that simplicity lay one of the defining lessons of the Second World War. Sometimes, the good enough solution, produced in great enough numbers, wins the war. This principle, designing solutions that are good enough for the mission, rather than chasing technical perfection, became a cornerstone of modern systems engineering. The best solution isn't always the most advanced. It's the one that meets the requirements, can be mass-produced in time, and uses resources that are actually available. That lesson, symbolized by the paper drop tanks falling across Germany, still holds relevance in both military and civilian engineering today. The Mustang. Engineering excellence through practicality, the aircraft that carried those tanks. The P-51 Mustang remains one of the most successful fighters in aviation history. Its balance of range, speed, reliability, and manufacturability made it the perfect escort fighter for the Allied strategic bombing campaign over Europe. The Mustang's success was not the result of any single innovation, but of several interlocking factors. Its aerodynamically efficient airframe, designed by North American Aviation's engineering team under Edgar Schamude, provided an ideal foundation. The Rolls-Royce Merlin engine delivered exceptional power and dependability. The addition of a fuselage fuel tank extended its endurance, and the use of external drop tanks, often made of paper, pushed its operational range beyond 800 miles. No single component made the Mustang great. It was the seamless integration of design, technology, and industrial scale that transformed it into the decisive escort fighter of the European Air War. Rechlin's revelations 80 years later, the lessons of March 1944, remain deeply instructive. When German engineers examined captured American equipment at Rechlin, they uncovered more than just technical details. They saw the strategic truth behind them. The paper fuel tanks revealed that the United States possessed an industrial power that Germany simply could not match. They showed that American engineering prioritized practical efficiency over perfectionism, and that the Allies had the resources to make design decisions based on optimization, not desperation. These realizations came at a time when the war's final outcome was not yet sealed, but its direction was becoming increasingly clear. For the German technical staff, the implications were sobering. They understood the challenge before them, yet also knew it was one they could not overcome. The engineers at Rechlin continued their meticulous work measuring paper, cylinders, calculating fuel capacities, and analyzing their construction. But even as they documented these details, they recognized the larger truth: that industrial capacity, not engineering brilliance alone, would determine who won the modern war. Endgame. When production decided victory, the war in Europe ended in May 1945. By then, the systematic Allied bombing campaign, made possible by long-range fighters like the P-51, had crippled Germany's war machine. Factories lay in ruins. Transport networks were shattered. Fuel reserves had run dry. And the Luftwaffe, once the terror of European skies, had been reduced to a token force. Many factors led to this collapse, but the ability to escort bombers deep into Germany, thanks to fighters carrying drop tanks, including those made of paper, was among the decisive advantages that sealed the outcome. a legacy beyond the battlefield. Most of those paper drop tanks did not survive. Some were collected by museums. Most were destroyed or discarded after the war. Yet their true significance lies not in their fragile construction, but in what they represented. They embodied industrial strength guided by strategic purpose. Appropriate technology applied to a specific problem, and the power of mass production used intelligently to achieve dominance. The story of those tanks, preserved in technical reports from Rechlin and other wartime archives, continues to shed light on the deeper nature of World War II and the industrial realities that defined it. In the end, the humble paper drop tank became far more than a disposable fuel container. It became a symbol of how practicality, scalability, and efficiency, not perfection, can win wars.